an association for machine learning, Italian Association for Machine Learning. We are one of the communities in this association. This is the staff, the people who are behind the organization of those events. And if you would like to know more about, would like to be part of this stuff, we are looking for volunteers who would like to join. In particular, we're looking for a social media manager to help us on promotion on social media channels. This is our website, www.datasciencemilan.org. On this website, you can find all the information about this community. You can find recordings of previous events. You can find the slides. There is also a link to our blog on Medium, where we post summaries of the events. So if you missed one of the event and you just want to have like a quick recap, or you're looking for links, any follow-up on the event, you can find it on our blog in the articles that are written by Claudio. The monthly digest, this is another service we offer to the community members. We send one email every month, only one. And our newsletter manager, Ricardo, he's in charge of selecting only the relevant articles, relevant events you might be interested on, as well as news from the community. So if you want to join, please go to digest.datasciencemilan.org. And we also encourage you to join on Slack. This is the place where you can find all of the community members, at least the one who joined Slack. And you can have this 24 hours every day conversation if you want to ask questions, even suggestions, or seeking feedback for ideas, even technical topics. You can come to this chat and ask the rest of the community. If you wanna present, you can send us an email, datasciencemilan@gmail.com, and we'll be more than happy to have you as a speaker to one of our next events. Now, in terms of Wallboard, this is like the place where we put like news from community members or from companies that are connected to the community. And we would like to promote this podcast. It's called Intervista Pythonista. It is in Italian, and it is managed by one of our community member, Marco. Another event that you might be interested on is the Feature Store Summit, which is happening next week. You can find more about on featurestore.org. And yeah, if you want us to promote something to one of the next event, just send us an email with your content, and then we'll be happy to promote it here. All right, so the agenda for today is with Peter, who is a technology evangelist at Imply, and we'll be presenting this talk about this large-scale data system. Just before we start with the talk, please help us spreading the word. So during the event, you can take snapshots, you can send tweets, messages on LinkedIn, on Facebook. Those are all of our accounts, so please help us on spreading the word. This is it, and enjoy.
Cool. Thank you. Now, I'm going to pray to the screen sharing gods that this is working all right. Can everybody see? You can see the screen all right, guys? Good. And also, everybody, so today I treated myself to a third screen. So now I have a screen down here with everyone on. I have my laptop in front of me, and then I have the main presentation on the right. So if I'm doing this all the time, please forgive me. So the talk that I'm going to deliver today is about Apache Druid. It's entitled Data in the Hot Lane. I'll tell you who I am, this good-looking guy you can see in front of you. My name is Peter Marshall. So I'm a technology evangelist. I work with the open source community out of Imply in the community team. I've got about 20 years experience in enterprise architecture. I've covered lots of different platforms, services, applications, whatever we call them nowadays, across lots and lots of different industries. I have a degree in theology and computer studies. I guess someone said last week that it's the first time they've met a technology evangelist who is actually qualified in theology. That would be me. I'm TOGAF certified, which means like I should be in some kind of hospital or under arrest or something. It's an enterprise architecture qualification. I buy lots of books and then I don't read them. I don't know if everybody else feels like that sometimes. I have shelves full of books on Python and stuff that I've never read. I believe that the prime timeline in Star Trek really is the only timeline. And if you're a Peloton user, hi, I'm on Peloton. So yeah, go Peloton. Okay, so in this talk, I'm going to talk about where Apache Druid came from. I'm going to talk about how we describe how Druid should be placed in a data ecosystem, like what it's actually for. Then spend a bit of time about how we describe the journey of Druid actually being developed, and then go into the detail a little bit, talk about how Druid actually optimizes the data and help you understand why it might be different to other databases, and then give you some pointers to learn more things. And then we've got time for live questions at the end of the talk as well. So the Druid story, where did Druid come from? So back in 2012, it was a company called MetaMarkets that open sourced this new database. MetaMarkets worked with advertising exchanges. If you're not familiar with advertising exchanges, they're companies where publishers offer up different advertising space that various advertisers can go and bid on. It's a very competitive marketplace. Anyone working in this industry therefore has to prove that they offer the best publishers and that they can give people the best click-through rates, the best positioning in front of the right audiences. And to do that, they have to present evidence to people. And they have to do that really quickly within, minutes of an advert being placed. And that's very large data sets, very fast arriving data sets. And the business problems of our, the 3 Vs, volume, velocity, is precisely why MetaMarkets and their engineering team did a full review of everything they could find on the marketplace to find out the right database that they should use. Because the technologies they were using at the time couldn't deliver that evidence. They couldn't deliver the insight into the services. Their technology stack was very unscalable. The data was disjointed. What they could do with the data was very limiting. And there was a distance of speed by which, we say high latency between the data being produced and the actual decision makers sat at the desk. So it meant that end users had very few dimensions to filter and sort and group by and drill down into. They had predetermined metrics to analyze the facts of what was happening. And they had very limited context to understand the causes and the effects of the decisions they were making. So they had very stale data, very out-of-date data. So they tried to use things like Greenplum, distributed Postgres, so that in the face of the cost of that, though, they tried to use something else. They tried to use this newfangled thing called big data. Oh my God, remember the days. So they started to adopt Hadoop, and they put H-based jobs on there to create this user interface they wanted to build for these decision makers. But when they tried to do things like add a new dimension to the data, those UI-focused jobs, instead of then taking 12 hours to refresh the data, started to take 24 hours. And that was something that is just not acceptable when you're trying to be the next big thing in Silicon Valley. So the team of engineers did this huge review of all their options. They looked at SQL on Hadoop query engines. They worked out that they wouldn't be flexible or responsive enough, that data warehouses wouldn't be able to ingest data in real time, that the search engines wouldn't be able to calculate things quickly enough. So like mad people, they decided what they would do is they build a new database. So one that would give them the upper hand in this competitive marketplace. And this is what they built. They built Druid, later became known as Apache Druid. And it's described like this if you visit the project site: a high-performance, real-time analytics database. So what does it really do? What it does is give business users, software engineers, and data scientists the ability to get at fresh data really quickly on all sorts of data, and to get at that data, the statistics in that data, on demand. So they built this. So they created this quite unique interface at the time. To my eyes, it doesn't look Angular enough anymore. But they built a web and a mobile service to democratize all of the events, the billions of events they were receiving every month. Their end users were people like account managers, advertisers themselves. And with this interface, they could do real ad hoc queries. And this really quite flash user interface. They could slice and dice on 30 different high cardinality dimensions. And they just couldn't build this without building a new database, without building Druid. Eric Schetter, we affectionately call him Cheddar in our team, was recently interviewed about the whole story behind Druid. And I really recommend taking a listen to that post. And also you can read the full review right in the technical detail of the different technologies they looked at before they decided to build Druid. And it's in the Druid white paper on the project site. Again, do go and have a look at that. It's really technical. You know, some of us love that stuff. So one of the first adopters of this new database was Netflix in 2013, just months after it was open sourced, actually. And by 2015, when the first project committee met, the adopters included eBay, PayPal, Cisco, Yahoo. By 2016, well, you kind of get the idea, right? Salespeople always show you logo slides. I like this logo slide. There's some really, really cool companies that picked up very early on. One of those was Yahoo. Tim Tully was the vice president of engineering at Yahoo when he wrote this about Druid in the blog post, an InfoWorld interview. He said it can do very large OLAP style processing on the fly in hundreds of milliseconds instead of pre-calculating everything. The performance is great. Some of the tables that we have internally in Druid have billions and billions of events in them, and we're scanning them under a second, which is great, right? Brilliant soundbite. Thank you very much, Tim. The three things that I want to pull out of what he said, though, really highlight what Druid's about. First of all, it's OLAP style stuff. So Druid is there to help you focus on statistics and generating statistics on the fly instead of pre-calculation. So by using Druid, you can increase the speed and the responsiveness of those really cool user interfaces, while also reducing the overhead of maintaining that pre-calculation in the pipeline. And thirdly, he's talking about billions and billions of events, right? Not all of us have billions and billions of events. Yahoo obviously do. Don't be scared. Not everybody's Yahoo. Druid is great for those smaller data sets as well. So they created a database, mad thing to do, but they did that so that they could scale in and out, up and down independently for the storage, the query, and the ingestion capabilities, so that they could bring in data in real time and in batches, and that they could use for all sorts of queries, free of pre-computation further upstream. And that let them remove anything that got in the way of low latency delivery of stats to their end users through that interface, which is cool. Well, under the hood, Druid is a blending of different database technologies. And it's the kind of technologies we've all been familiar with for very years. In fact, Eric Schetter said just a few weeks ago that that's the true innovation of Druid. It's taking what we know and what we've learned about database technologies and applying it to create a database that, importantly, is focused on the end user, about what the end user wants to do. So Druid brings together the ingestion, flexible schema, and text search capabilities we'd find in search platforms. It has optimizations for time series data you'd find in time series databases. That's really critical for all sorts of business decisions where you want to make comparisons over time periods, things like that. And it also has the efficient storage technologies we'd associate with columnar databases, that allow us to do those really fast statistical calculations. Applying learning, right? That's the magic here, because it really works. The ingestion in Druid can scale to many millions of events per second. The query engine scales to give hundreds of users answers to all sorts of statistical calculations at sub-second speed. What's more, not fixed by pre-calculation. And the storage system is this OLAP optimized, very compressed storage system. So you can give people real-time data. Yes, that's cool. But you can also give them that unified view of what's happening right now and what's happened in the past as well. So that's where Druid came from. So when should I use it? What kind of use cases are there out there? Well, we use this temperature slide. Now, this slide was put together by my boss, Rachel Podreski. She's the Vice President of Community at Imply. So everybody, please thumbs up this slide. It's the best slide in the universe, obviously, because my boss made it. And she uses it to try and categorize the use cases that we have for Druid and different data technologies, actually. So in the top lane, we have those hot use cases, we call them. So we have this beautiful, tasty bowl of those kind of, you know, those Cheetos that make your fingers go yellow, those kind of Cheetos, the really hot ones. And at the bottom, we have colder use cases where we've got a warehouse filled with cheese, apparently. It's even in black and white. Look, she's done it to do that, to make it look like it's really cold. Of course, so this is a scale in reality. There are gray areas in between, of course, but for illustration, I'm just going to use these extremes. So let's start with the cold data use cases. Now, this is a place where we probably don't care about how slow the queries are to run. We might be okay with minutes or even hours, because the service that we're offering as an IT department to the business is a lot more about standard reports. It's a lot more controlled. It's very carefully curated with good reason. The output is fairly predictable. And we've got loads of processes and teams in the business whose job it is to just churn this stuff out. So we're not going to have that many people using that data source directly. So it could be just our professional data people, data scientists, people who know the entity relationship diagram back to front. They know it inside out. They know where things are. So cold data is more for careful planning, careful consideration. It's less about making instinctive decisions, less about gaining understanding through exploration or by comparison, or of instant flexibility and slicing and dicing, because all of that lives in Rachel's hot lane, in the hot use cases. So here we've got a hot user interface. So we're thinking here, if we're going to build this hot user interface, the queries have to come back in sub-second speed. The data has to be as fresh as possible. We're going to have lots of people using this. There's lots of queries running at the same time. And on top of it is an interface that allows people to explore the data, or we say to have a conversation with the data. Now, that freshness means that often people who are using Druid aspire to be using real-time data, so data about things that have just happened in the past few hours. Concurrency matters because the data is now critical to business decisions. So that means we want to put it in front of a large number of people, not just data people, but end users, product managers, marketeers, that kind of thing. The knock-on of that is that people are going to spend a lot of time inside this tool. They're not just going to make themselves a nice cup of tea and go home. They're going to spend a lot of time doing investigation, doing that interactively, what we used to call online analytical processing. So what kinds of use cases do we put into that hot lane? Risk and fraud analytics is one of them. There's a real need to deep dive into the data to figure out what's really going on when you get an alert, and to do that really confidently and do it quickly. You might build a data-driven application. So you might embed something into your website or maybe into a mobile app. And in that case, concurrency is going to be really high. You're going to have a lot of people, maybe people outside the organization, customers and suppliers you're working with, who are all accessing that user interface directly. Network performance is a very common use case for Druid. It's very operational in nature. You need to have fresh data. You need to know how to act very quickly. In click streams is another good use case for Druid. That's where the freshness of the data matters for knowing how many people you've got on the site immediately, for example, but it also is useful to have a look at the historical data when you're looking at rollouts of new channels or doing A/B testing. You need to be able to explore the data and slice and dice over both real-time and historical data together. And by clickstreams, I don't, of course, mean web analytics. I mean like video streaming and that kind of thing as well. Okay, digital advertising. So digital advertising is that kind of marketplace everybody loves to hate, especially when you're trying to play Angry Birds. But even the smallest companies involved in digital advertising generate massive amounts of data. So you've got to keep up with that data. And you've got to have this ability to scale the query capacity. Well, that's a place where lots of interesting technology that you and I know, I've known for years, around us in the big data world has come from, and that includes Apache Druid. Remember, Druid was built to solve a real business problem. It wasn't just a research project. So all of these problems, they all require a database that can scale with the number of users, where you can get fresh data in front of people, where you can do exploration. And that's what we say makes them hot use cases. So as a hot database with its low query times, Druid can make analytics personal and interactive and very intuitive. And the scalability means you can reliably expand the audience for that analytics. And when it comes to ingesting data, ingesting fresh data from stream sources allows people to make rapid decisions, instinctive decisions. That's cool. But, you know, instinct is one thing and good reflection is another. You also need to temper that so people don't overreact with data that allows them to have good reflection by looking on the historical data. So these kind of user experiences. So guys, confession, I'm 44, right? I'm old by IT standards, right? I remember when people used to write report specifications and give them to me on a memo, and then I'd go and write them in PL SQL. This is different now. This is a world where we have people, Gen Z people, where hot user experiences really matter. And they're demanding things that are personalized and very adaptive, where they're very simple and intuitive to use, where people can trust what's in there. So obligatory Gartner quote, everybody, please forgive me. It's that kind of customer who's driving the democratization of analytics and therefore of decision making. It's creating a demand for citizen data scientists. Scary thought, I know. But through 2021, the number of citizen data scientists will grow 5 times faster than the number of highly skilled data scientists. I'm sure they probably wrote this before we all got locked in our rooms for a year and a half. So people need to access the data even more than they did at the time this was written, I'm sure. So when you have hot end users, like those Gen Z customers, when you're trying to create hot user experiences, you are going to run into problems of scale. You're going to run into problems of high concurrency. You're going to need streaming ingestion. You're going to need to do ad hoc exploration. So you have to have a database like this that scales well, that performs well. And as I said earlier, that empowers the end user. That's why they created Druid. It's all about that person on the desk. Ingesting 100 billion rows a day, retaining trillions of rows of data, scaling up to hundreds of servers, query latency in the sub-second, streaming batch ingestion. That's all part of Druid's DNA. That's why it's there. So what might I use as a user interface to Druid? What's out there? Well, for decision making in the business, you might use Looker, you might use Metabase, Superset, and so on. And they connect to Druid's JDBC driver, which is provided by Avatica. With Druid's SQL API, you might build some custom applications. Remember, these are really cool applications. They're fun applications, very interactive. They're the kind of user experiences that make you look different to everybody else, where you're reaching more people, where they can do more stuff. And finally, maybe data scientists will use Druid as a hot data source whenever you need to do time-based aggregations, especially comparing time periods. So Yahoo and Facebook have both done work around this. They've provided Yahoo Sherlock, which does anomaly detection, and Facebook Profit for predictive analytics. And there's blog posts all over on those, especially it was one written by Preset recently, a company who's involved with Superset, about how they've used Superset with predictive analytics and Druid. It's worth a read. So whoever these people are, whoever I'm going to talk to you about, they're all trying to build these hot experiences. On this table, I've tried to summarize what the differences are. And there's an emphasis on that speed, on democratization, on exploration. I think you're kind of getting what I'm saying right at this point. So I wrote this blog post last year, my goodness, after Druid Summit. And it summarizes a bit of a meta study of the kind of qualities of the applications that get built on Druid. So do go and have a look. It might inspire you to think differently about the kind of user experiences that you can give people on your data if you adopt Druid. So that's data temperature. Now then, how on earth did we end up getting here? So it all kind of started in the mists of time relational databases, right? You know, I remember when I installed Oracle 6 for the first time. I think it had Forms 4 on it. Anyway, this is my land, right? Where all my orders, all my stock, all my customers, my suppliers, everything that we need to operate a business is here. That single database, everybody's querying that. We've got reports and analytics happening on there. I mean, why not? It wasn't that big at the time. Nobody had that much data. And you had people you hired whose job it was full time to curate and collate all this data. But you see, data has this really nasty habit of accumulating. No one deletes anything anymore. And businesses have this really nasty habit of going through things like digital transformation. So both the data and the questions that we were asking changed. So now there's this tension between operating the business by using a database like Oracle. Is it over there or over there? Using a database like Oracle and actually understanding the business, the difference between operating it and explaining it right down here at the technical level. So enterprise architects like me with my beautiful cat, my beautiful hat and my rainbow coat, we all said, well, a brilliant idea. We should all go and build this thing called a data warehouse. So we did. The important thing is that we learned something really important when this happened. And that is that OLTP, like the thing that runs the business, and understanding the business, doing analytics, are two completely different problem spaces. At the very heart of it, right down here in the technology, we have relational databases running the business, and we have a warehouse that explains it. So by moving all that stuff we used to do away from the operational database, by offloading it, we're minimizing the impact on our business. So we get some nice new logos, fantastic logos like Netezza and Greenplum and Teradata. And of course, Oracle and Microsoft had to respond to that. And between one and the other, you have to design and develop and maintain a process that will turn that operational data into data that can be used for decision making. You know, we know that as the schema on write approach. And that gave rise to the first problem. We spend a considerable amount of time analyzing data sources. We understand the business processes, trying to cleanse the data, trying to structure it specifically for reporting, and to simplify the data model to make it usable by end users, and thinking about how much the hardware used to cost. And those projects could take years and years and years to do. But even worse than that, the data is still continuing to accumulate. And the questions that people want to get out of the data continue to accumulate. So those technologies end up getting even slower again, but then we try and scale them. Well, data warehouses are difficult to scale. So eventually we end up, you know, what the hell are we going to do now? So now we're in the 1990s. And as everybody around us starts to realize that data's worth something, that it has a value, the industry, you and I, had to wake up as well. So now we decide, well, we've got to warm our analytics back up again. We've got to do something better than we did before. So now I have a new set of database technologies. They're responding to the digitization of businesses and to knowledge ecosystems, personal passion of mine. And we create databases just for analytics, these OLAP databases, things like Click and Cognos. We've got these cool user interfaces, many more design elements, a lot more interactivity, easier access to data, even if it's just summarized data. In IT, we can start to open the door a little bit and open the gate a little bit to more data. And then the internet arrived. And everybody started to scale out, not scale up. Why would you have one relational database? That's insane. Don't say something like that. Now we want you to shard those relational databases, and using new database technologies like MySQL and Couchbase and MongoDB. And instead of putting all the transactions into one database, we split them up and we scale our business operations to internet scale. And what about analytics? Some of you may know Pentahost CTO James Dixon was generally credited with coining the term data lake. Warehouses, we know, have this kind of cleansed, packaged, structured data. But a data lake is more like a body of water in its natural state, with data streaming in from lots of different sources. And to look at data at that scale, we needed new engines, things like Hive and Trino and Kylin. Since all the data is stored in its raw form, we've got a really big advantage, because we can now free our analytics from the rigid structures that we had in the data warehouses. Now, anyone can query and explore the data in ways they hadn't thought of before. And because the query engines don't change the data, there's really a lot of flexibility. So now we're in the land of data on schema on read. But notice that we still have to do some of this work, right, to make it statistically ready. We still have to do cleansing. We still have to do enrichment, denormalization, sessionization. But where it's done is now more distributed around the different technologies, hence the arrival of the role of data engineer and all the money that goes with it. So 2010 comes and goes, and now the number and type of source systems is insane. We don't just have relational databases putting stuff into a lake. We've got distributed know-nothing applications, and we've got data from mobile phones and medical appliances and beehives and cows' feet. And as well as batch ingestion, now we have the option of putting individual rows, individual events onto things like Kafka and Kinesis and Pulsar and Azure Event Hub. And instead of ETL tools now just being oriented in batch processing, now we can do all kinds of really cool magic by processing the events on the stream as they happen, bifurcating sources, enriching, normalizing, loads of really cool things. So this is a really scalable architecture, right? This is wicked. We can scale our databases, we can scale the data processing, we scale the data storage and the data lakes, we can scale all these analytical engines. So now struggling to keep up with that are us analysts, where we've got, we want to have interactive, fresh, fun, even interfaces. So we try to adapt database technologies that we've got. So we try to use things like HBase and Cassandra. But in the industry, as MetaMarkets taught us when they spawned Druid, we'd forgotten a really valuable lesson. And that is that OLTP databases are not for OLAP. This is exactly what community members using Druid realized as well. That's why these big companies have adopted Druid. It's the lesson that MetaMarkets learned. Druid is the OLAP database. It's written for OLAP on these kind of systems for these hot use cases. You don't have to worry about HBase exploding if you add one more dimension for analytics anymore. And its purpose is to take data, to make it hot, ready for these new end users, specifically for statistics. And it has one extra piece of magic, something that pulls us out of batch architectures, something that really has revolutionized decision making. You see that data lake there? That's adding latency. So let's get rid of it. Let's do something different. With Druid, I can connect directly to the stream instead. So when I use in-flight data processing in things like Spark and Flink, that data arrives decision ready immediately in front of the end user. To quote one community member who's adopted Druid, Druid is the best implementation of a Lambda architecture available today. And the Apache Druid community, which includes contributions from big Silicon Valley engineering teams, they're all driven to build the best OLAP database possible for these end users. We're talking about hot user interfaces where we've got very fast statistical computation, very high concurrency, and where people can do ad hoc stuff with their data. Druid is all about speed. Druid is all about driving the data down the fast lane. And a benchmark done by an academic research group in Portugal showed just how fast Druid can be. They estimated a 59 times speed improvement over Presto, 100 times or more over Hive. But why? Why does that happen? Druid has got 4 big strategies that make a big difference. First of all, data in Druid is compressed, it's columnarized, and each column is compressed based on its type. Secondly, it constructs indexes. That's something that query engines on data lakes don't regularly do. Thirdly, when a query executes, the operations act on the compressed data as a priority. The raw data is hardly ever touched. And in fact, that's why it does late materialization. In other words, the work of actually constructing the final result happens as late as possible. So the cost of this, though, is that Druid has to ingest your data. It is a database. It doesn't go to a data lake and scan the data to create results like Trino would. It reads the data ahead of time. It partitions and indexes it. It balances it across all of the nodes in the cluster. And that's beyond what a simple query engine would do on top of a data lake. But the promise is that you get these really, really fast query response times. So I can heat up data in batches. Maybe I'll do backfilling. I can consume data direct from the stream. And I'm bringing the data to Druid to let it go and do its magic. So thinking back to that benchmark, ingestion of data and optimizing that data, that's one of the reasons why you get this query performance. And it's why you get a better performance on the same hardware and a lower performance floor. Other engines don't bring the data that close. They don't optimize it in the same way. So that's one of the reasons. In the other data lane, though, that's still really important. This isn't an either or to me. You can do other things that you don't need to do for a hot user interface. You can query things you haven't looked at before. You can access data sources through federation. You can use spot elasticity. Now, all of that work may make the query slower, but that's okay, because in that lane, you're not powering the same kind of user experiences that Druid is there to do. So finally, it's worth noting that both of these databases are fault tolerant, elastic, and shared nothing, etc., blah, blah, blah. But remember that Druid is a database. When you add a new Druid server, that server doesn't participate in queries until it's been loaded with the data. Whereas with query engines, you can scale it up and you can use that new processing capacity really quickly. So there's different temperature here, is I guess what I'm saying. Cooler stuff in one lane, hotter stuff in another lane. When you go and look at the Powered By page, you're going to see a mix of technologies across all of those use cases, depending on which end of the temperature spectrum the user is living. Okay, so I'm running low on time, so I'm going to be as quick as I can with this one. Guys, are you ready? Deep breaths. So let's look at how we can use Druid to treat the data when it's actually ingested. Now, when Druid ingests data, it's kind of creating this series of shards that it can distribute and replicate across the cluster. And when we ingest data, it's creating a timeline. Remember, it's a time series database as well as all the other things as well. And they're all sequential intervals. If you look in the docs, you'll see them called time chunks. And they're all distributable packs of data. We call them actually segments. We can also sub-partition the data. That's really helpful if you have a particular dimension that you're always doing particular work with. We can use hashing or ranging sub-partitioning for that. We tell Druid what to do in what's called an ingestion specification, saying what it is, where it is, what the dimensions are that we want. And we can also apply row filtering and row-wise transformations as well in that ingestion specification, so that those things happen in real time and they're queryable straight away. Once you've got your data in, this is where Druid starts to do the magic. It's going to turn the row-wise data into a format that's specifically for ad hoc analytics. So it columnarizes it, it adds those indexes, and it compresses it. So here's an example table that I have of some strange shop where they only have 3 customers. I've got when the transaction occurred, who was there, what they purchased, what the stock level was after they did what they did, and then whether they were happy or not. Remembering this was written at high speed. When it arrives into Druid, it did it in row format. So this is no good for analytics. If I want to work out the average satisfaction, I have to do reading from left to right, adding up the satisfaction and dividing it by the number. It's a bit daft. It doesn't scale very well. So what Druid does is it columnarizes immediately. So when I ask what's the average satisfaction figure, now I only read the satisfaction column and I ignore all the others. So that allows Druid to have lots of dimensions in its data store, high dimensionality data. All of the columns are stored and analyzed separately. Now, remember that timeline? Look at this when column. This particular segment that I'm looking at only covers a particular time period between 12:30 and 1. So 2 benefits here. First of all, if I want to ask Druid to compare 2 periods of time, it's going to do that in parallel by processing 2 segments separately. That's really important for things where you want to compare one statistic on one day to one statistic on another. Secondly, it allows Druid to hunt through much less data when it's asking its question. It knows which period specifically it is that I want to go and look at. It doesn't do a huge table scan. It goes specifically to this period because that's what my query is addressing. Now, my talk's going very, very quickly right now. If you're trying to keep notes, it's probably quite difficult. One of the tactics for dealing with that in the past, fast arriving data, was to use a codex like this one. So a codex allows us to turn this flow of data into a codified version. It's very small to store and it's very fast to read. It's exactly what Druid does. So if you look at those who and what columns, it's created a codex, and the columns themselves have a dramatic size reduction. But it's also great for analytics because when we combine that with kind of an index of the codex, Druid is creating a bitmap index that's recording the coverage of each of the entries in the dictionary. You might know those as inverted indexes. Again, it's just learning from the past. So Druid can now use that information for really fast filtering a whole load of different operations. So take, for example, if I wanted to do an AND or an OR type filter, now I can do a binary operation without scanning the data. So all those columns that we have on the left-hand side are great for filtering, sorting, for calculations, for aggregations, etc., etc. But there's one other thing that Druid can do as well to reduce the size even further and make it even more efficient. And that's something called Rollup. So imagine you're working with a team. They're very happy with 10-minute summaries of the stock and satisfaction levels. They don't need to know what the satisfaction was second by second. And you also discover they don't want to filter by the customer. They're interested in trends and overall behaviors. Again, we're focusing on the end user here. So in Druid, I can create things called metrics. So instead of looking at the actual stock change values individually, what I'm going to do is I'm going to summarize them. So we're going to take the stock change value and the satisfaction values, and we need some way of doing a count distinct of the people, but we don't need to know specifically who they were. So I'm going to employ Rollup. Most people who are using Druid are using some kind of Rollup. So keep an eye, first of all, on the when column. The first thing I'm going to do is I'm going to reduce the granularity of that timestamp. In fact, I've set it to 10 minutes. So instead of individual timestamps stored, now I just have 3. That alone has good compression advantages. The second step is in Druid. I'm going to say, right, give me the sum of the stock and the max of the satisfaction over those periods. And it emits rows just for those. Now in Druid, we get a new row for each who and each what within that time period. So here, 1230 is only going to be summarized into 2 rows. Our first row for a who of 1 with a stock change of 5 and a max satisfaction of 5, and then a second row with a sum stock change of 17 and max satisfaction of 4. For the other columns, though, and this is a big problem with these large data sets, I've got a high cardinality column, and it's causing every row to be emitted for every input row. So we're going to use something very clever. It's called an Apache data sketch, a hyperloglog data sketch. If you haven't heard about those, go and read about them. They're really cool. And I'm going to remove the who column, and instead I'm going to store a sketch. And that allows me to still do approximate count distincts really, really quickly without having to store the original values. There's other data sketches too. It's worth going and look at theta sketches of a set operations. So if I wanted to work out how many people have visited in one time period but not another, I can do that. And then I have a quantile sketch that's really important for telecommunications and for application performance monitoring, because I can do things like calculate 98th percentiles, for example. So take a look back at this original table, compare it to the data that's actually stored on the right-hand side. You can just see how much optimization Druid actually does. It's not only shrinking the data, it's reducing the scan times in the database as well. But these are all by industry proven optimizations that make the data inside Druid perfect for statistical analysis. And what's more, to do that really, really quickly. So I'm glad I got through that. That was quite good timing. Do go and have a look at the Powered By page. There's 160 companies now on the Powered By page. Splunk, Nielsen, Expedia, Swisscom, WalkMe, Zscaler, loads of them. Someone you know from your personal life, your business life, has put their name on here. And of course, there's lots of others who remain completely top secret. You can contact the community team, community@imply.io. And if we'd be happy to help you learn more about each of these use cases. We can even put you in contact with people if you want to know more about what they're doing. There's also the tag browser in the Druid forum. If you go in there, you can just click on different technologies and understand how it fits together with Druid. Like, say, for example, you want to know how to use Kinesis with Druid. You can go and have a look through there. Go and have a look on the project site. There is a quick start. You can just download the distribution, install it really quickly on any Mac, any Linux environment, and just ingest some data and just have some fun with the query engine. And if you're an engineer, please go and look at the GitHub page. Loads of issues, loads of pull requests. Go and have fun, I suppose, in GitHub. As a team, we're always regularly interviewing community members. We're writing community spotlight posts on the Imply blog. Do go and have a look. These are all open source blog posts talking about how people are actually using it. There was one just published last week on Apache Pulsar being used with Druid. Lots of really cool stories. Anyway, it's a very cool community to be part of. A very small development team 10 years ago. Now we've got over 30,000 members in every country of the world using Druid. Come and say hello to us in the Druid forum. Come to a Druid meetup. Join the professionals group on LinkedIn. And of course, follow Druid.io on Twitter. Thank you very much, guys. So questions, I guess. Do we have questions? Thank you for inviting me. I hope it was interesting.
Hey, Peter.
Hey, I'm still here. I'm lurking.
Okay. Yeah. I mean, as I said, we will follow up with if there are questions from the YouTube stream. And if you can also share with us the slides, then
Sure
we can
thing.
post it in
Yeah.
our slide share, and then everybody can see them.
Cool. No worries.
And
I
if
should
you
also
have any article, share with us, because we're gonna put them in the blog post we're gonna do right after this event as well.
Cool. Yeah, I can send you all the
thank you
links
very
to
much.
the different stuff that's saying you're welcome. You're welcome. I should also have said, but I didn't say, that it's Druid Summit in the second week in November. So do go and have a look at that. Lots of companies talking about Druid.
Awesome.
You can tell I'm excited about Druid. I think that comes across right.
Yeah, send us the link and we will distribute that to the other community members who were not able to attend today. We can send a follow-up email with all the relevant links.
Cool. Yeah, lovely. Cool.
Okay.
Thank you very much for inviting me.
Thank you, Peter. Thank you for your talk. That was amazing. Have a good
You're welcome. Thank you. Cheers. Bye. No worries. Bye.